Hi everyone. I'll just share my screen real quick and we'll cover some examples related to percents. Can you guys see my screen? Is it big enough? All right. So this is the first problem that we have. It's an extension example relating to percents. So the problem says that I buy a T-shirt that costs $30, but today is a special day. It is on sale for 25% off. So it asks me how much do I need to pay to buy the T-shirt. Um, so first of all, right, it says that the uh, it says that the like the store has a 25% off sale. Um, so if it has a 25% off sale, that means that in every percent problem, we always start with 100% because 100% is the whole thing, right? So 100% um, is the kind of the whole thing, right? So if you have $30, then um, you know you $30 is basically 100% of 30, right? As Daniel mentioned in the previous example um, with 50, right? So 100% of 50 is 50. So 100% of 30 is going to be 30. So 30 is going to be the 100%. But then it says that I don't need to pay for 25%, right? So because it says that it is on sale for 25% off. So that means that I don't need to pay that 25%. So from that 100, I can take off 25%, right? Does that make sense to everybody how I did that? Because it says that the t-shirt's on sale for a certain price, but then I take off 25%. So the actual price that I need to pay is 75%. Does that make sense? Let me know if any of it doesn't make sense. Because, yeah, all right. So 100%, I start with 100%, which is the original price. That's $30, right? And then um, I don't have to pay for 25% because it says that the uh, store has a certain sale for 25% off, right? So I don't need to pay the 25%. So I'm left with the 75%. And so how much do I need to pay to buy the T-shirt today? So I said if 100% is 30, then how much is 75%? Yeah, as someone mentioned, yeah, it is three-fourths of 30. So to demonstrate how we got to that, right? So as Daniel was saying, with proportions, right? So you need to multiply or divide by a constant to keep the proportions the same, right? So if it's 100%, then it's 30. Then if it's 75%, what do you do to the 100? You multiply the 100 by three-fourths, right? So if you multiply by three-fourths on one side, to make the proportion the same, you need to do the same on the other side. So you need to multiply the 30 by three-fourths as well. And so if you multiply 30 by three-fourths, you get three-fourths times 30, which is something like 90 over 4. So you need to pay $22.5, as some of you in the chat mentioned. So yeah, that's right. Does that make sense how we walk through that problem? Just let me know if it doesn't make sense. Make sense? Okay. So that's a basic example of how percents work. Especially, it's a very common example. You go to like any store, any Nike store, any clothing store, you see sales, right? And so what does the sale mean? The sale means that you don't have to pay that percent. Like if it says 30% off, you don't need to pay 30% of the original price. You need to pay for 70%. So the next time you go to a store, now you know what sales and discount mean. Right. So now this is a problem that's building on concepts that we learned throughout. So it says that Sid has a bag of money, and every day Daniel takes out 25% of the money in the bag. But then Sid immediately adds $20 to the bag immediately after, right? So after 2 days, Sid has $40 in the bag. And so how much did he start off with? Um, I don't know where Sid gets the $20, but hey, it's part of the problem. So every day Daniel takes out 25% of the money. So how can we start this problem? What are the initial steps that we need to take to solve this problem? Does anyone have any ideas? No. All right. So what I'd suggest, yeah, make a variable, right? So we could make a variable that says x. So x is the amount of money in the bag, right? So it's the amount of money that I had originally, right? And then Daniel takes out 25% of the money in the bag. So this is the original money in the bag, right? And so if I take out 20, if Daniel takes out 25% of the money in the bag, how much remains? Because he's taking out 25% of the money, right? If he takes out 25% of the money, how much of the money remains? It's it's kind of it's kind of relating to the problem that we did before. Kind of a similar situation. So I have X amount of money. Daniel takes 25% of it. So how much money did he take? He took so if he takes 25% of the money, then how much money do I have? I have, yeah, exactly. So if he took 25% of the money, 25% is out of a percent, so percent, so it's a ratio of 100 out of 100, right? So 25% is approximately is a fourth basically in terms of fractions and ratios. So basically, when the problem says that Daniel takes out 25% of the money, it's basically that he took off one fourth of the money in the bag. And so how much is left? Three-fourths of the money is left in the bag. So three-fourths of X is in the bag right now. So I have three-fourths X, but then immediately after, I add $20 more, right? So now this is the new amount of money that I have. So this is what happens in the first day, right? So this is the new amount. Say this is Y, right? Um, and then what happens the day after? Same thing, right? But with Y now, because originally I had X amount of money in the bag, but now I have Y amount of money in the bag. So now it's the same thing, three-fourths Y plus 20, but now it's with the new amount of money that I have, because obviously I don't have the same amount of money, right? Because Daniel takes out 25% of it, and I add $20 more. So three-fourths Y plus 20, and we say that Sid has $40 in the bag after 2 days, right? So we can solve for Y, and then we can solve for X, because I think that making one equation out of X could get a bit messy. So just in terms of organization, I'd like to just solve for Y and then solve for X, right? So I'll get three-fourths Y plus 20, and I'll set that equal to 40, right? Because this is the amount of money that I have after 2 days. So first day so I begin with X. Then first day after all this happens, I have Y. And then the second day after all this happens, I have three-fourths Y plus 20, which is equal to 40, since I have $40 in the bag. So solving this equation, I get three-fourths Y equals $20 or $1.20, right? So Y equals 80 over 3, right? Does that make sense to everybody how we got that? Yep. All right. Um so Y equals 80 over 3. And now we need to solve for X. So we see that Y was equal to three-fourths X plus 20. So we do three-fourths X plus 20 equals 80 over 3, right? Is that making sense to everybody? How we got to this point? Just let me know if it doesn't. Yep, makes sense. I just separated Y and X because it would get too messy, but obviously you can do it in one equation. That's no problem. And so we can solve for x. We can say that 3/4 x equals um so 80 over 3 minus 20 is going to give me 20 over 3, right? Does it make sense? So x equals 80 over 9. Does that make sense to everybody? Yeah. So, hey, look, 80 over 9 is how much money? 80 over 9 is actually, if you calculate this, 80 over 9 is actually less than it's actually less than $10. So I had less than $10 in the beginning, but then I have $40 at the end of 2 days. So I gained money with Daniel taking 25%. So it's a win-win, I guess. Um, so we'll move on to this AMC 8 problem. This is a bit on the harder side. So actually, let's do this one first. So the problem says that a shirt regularly priced at $30 is on sale for 20% off. And Mary has a coupon that'll take another 25% of the sale price. So I have a shirt, it's $30 in cost, right? And I have it on sale for 20% off. But then Mary has a coupon that'll take another 25% off. So I get 20%, and then Mary will take another 25% of the sale price. So the problem says what single percent discount would give the same final price as the two successive discounts. So if they if the so that what the later percent so what the later part of the statement is saying is that since we get 2% off, right? We get the 20% off, and then we get the 25% off from 30. But then the problem is saying what single percent will give us the same thing, just like having 1% instead of like 2% off. So let's see. A shirt regularly priced at $30 is on sale for 20% off, right? Um so if I have it on for 20% off, how much money do I actually need to pay? So I have a shirt that's $30, right? And it's on sale for 20% off, right? So um how much money do I have to pay after the 20% off? Well, we can do the same thing that we've been doing so far, right? So 20% off, I don't need to pay the 20%, right? So I only need to pay the remaining 100% minus 20%, right? Which is going to give me the 80% that I need to pay. So I need to pay 80% of the price. So 80% of the price is going to give me, again, percent. So it's a ratio out of 100. So 80% is going to be 80 out of 100. So I'll have to pay um, $24 originally, right? Without the extra coupon. So Mary has that extra coupon, but I don't have that extra coupon. Now what Mary will have to pay is a further 25% off the sale price. So the price is originally $30. So we got that the sale price is now the shirt, but at 80% of its cost. So it's gonna be $24, right? So $24 is the sale price. And Mary has a coupon that'll take another 25% off. So what's another 25% off? Another 25% off is gonna give me um I have to pay how much money? 75% of the money, right? So 75% of 24 is gonna give me um again, I hope you can see why we did 75 over 100 and then we took 24 times. It's the same process that we've been following. Just you have an amount and you want to get the amount of money that you want to pay, right? So um 24%, $24 times 3/4, basically, right? Because 75 over 100 is 3/4. So that's $18. So that gives us the amount of money that Mary is paying, but it doesn't say what single percent discount would give the same final price as the two successive discounts, right? So we need to find what percent of the original price Mary is paying. So Mary is paying $18. $18 is how much percent of the actual price? So it's gonna so 18. So how much fraction or how much proportion of the money is Mary actually paying? Mary is actually paying 18 over 30 of the money, right? Which is 0.60, right? So Mary is paying point Mary is paying point 0.6 of the problem or point 0.6 of the amount, right? So so you have some money, and then Mary, after all these crazy discounts, Mary is paying 3/5 of that money because point 0.6 is equal to 3/5. So Mary is paying 3/5 of the money, right? So how much of the money is Mary not paying? Mary is not paying 2/5 of the amount of money, right? Because if she pays 3/5, then the thing that's left is the thing that's left is 2/5, right? So Mary doesn't pay that 2/5. She only pays 3/5, right? So if Mary doesn't pay that 2/5, the single percent discount that would give you the same final price as the two successive discounts is 2/5 is going to be what percent, as we talked about so far. So Mary doesn't have to pay that 2/5. It's 2/5 off, but obviously no store says 2/5 off. Yeah, it's 40%. So Mary's discount is actually 40% off. So on the store in the store, obviously, it'll only say 20%, but what Mary has to pay is 40%. So in the store, if the banner said 40% discount of a $30 T-shirt, then that's what Mary has to pay, and that's what Mary pays, right? So it's a 40% off discount that Mary has because um, after all these crazy amounts, it's like 40% of the total price that Mary has to pay. So you could say that it's 20% off and then 25% of the sale price, or you could just say 40% of the discount. 40% discount. Yeah. So Mary doesn't have to pay 40% of the amount of money that people are paying. So questions, or is everything good? Yeah, read the problem carefully because a lot of people or a lot of chats that I'm seeing is saying $18, but it says what single percent discount would give the same final price as the two successive discounts. So it asks for a percent, not an amount of money. So you would have to take the amount of money, you'd have to see how much that money was of the original amount of money, and then you'd have to find the discount. Yeah. So yeah, just read the problem. It's a very common mistake that a lot of people make in math competitions, including myself and Daniel probably as well. So just yeah, read the problem well, read the problem statement 2 times, and see what the problem actually asks. Because if you end up answering the wrong question, then you know that doesn't. Yeah. Mhm. Exactly. Yeah. Yeah. So this problem again was very misleading because it said that you could have found $18 and you would have been like, "Oh, I did this. I did like all this hard work. This must be it and done, right?" But you missed that single step that would have gotten you that one more point in the MC. So I'd say it's always worthwhile reading the problem twice. So we'll do this problem. It's from the 2020 MC8 and it's problem 15. So supposedly it's a bit hard. So it says what the problem says. Suppose 15% of x equals 20% of y. So what the problem says is what percentage of x is y. So let's try to understand what the problem is actually saying. So let's try to understand this statement. So what percent of x is actually y? So what the problem asks wants us to find is the percentage, right? So before talking about percents, I always like to talk about the ratios because you can just multiply the ratio by 100 and see what the percent is because the percent is just the ratio multiplied by 100, right? So I'd like to see what the ratio is. So it says what percentage of x is y. So it says so what the problem's actually saying is you have x and then how much of that x is y. So this is what the problem is asking you to find. And then for the percent, for the percent, you multiply that by 100. Because they think about it in terms of actual real numbers, right? So if it says what percentage of 15 is say 10, right? So what the problem is saying is what percentage of x is y. So what percentage of 15 is 10, right? So you'd find 10 over 15 and then multiply that by 100. So so that's what the problem is saying. Yeah. Um. So all we need to find is y over x, and then we'll talk about the percent later. But the ratio is what's important. So 15% of x. So what again? Let's talk about it. What's 15% in terms of proportions and ratios? Because that's what's really important. What a percent is this just a ratio multiplied by 100. So yeah, as one of you mentioned, it's 3 over 20 because you say 15%. Basically, I'll for just for the sake of going through it, I'll just talk about how we get this multiplied by 100 thing, right? So percent is a ratio out of 100, right? So we're gonna say that we have a ratio of like x over 100, right? Mm-hmm. Right? And so we want to find what fraction that is, what fraction 15 is out of 100, right? So we're gonna find something out of one here, right? Because what a ratio is it's a fraction out of one. So 3 over 20, as one of you found, is like 3 over 20 over the whole 1%, the whole like part. So it's out of one. And then if you multiply x, and then if you multiply both sides by 100, you get 3 over 20 times 15, or times 100, my bad. And that's 15. So that's how you get the percent. So it's like the ratio you have over 1 is equal to the percentage over 100. And by the way, the percentage x is relating to 3 over 20. But now, instead of having 1 as the denominator, you have 100 as the denominator, right? So does that make sense to everybody? Because like this is a fraction, right? And like you can have 120% of something, but we're not gonna say that here. So the we're gonna say um, the part that you're comparing it to is 1. So 1 is the whole part. And so 3 over 20 over 1 is going to give you x over 100. So you find 15. It's just but yeah, continuing this problem, it's 15 over the 100, which is going to give us 3 over 20. So 3 over 20, right? And then um 3 over 20 of x is, so as Daniel mentioned before, um of means multiplication, right? So 3 over 20 of x. So we need to find the, so it's like 3 over 20 out of x, right? So 3 over 20 times x equals 20% of y. What's 20% of y? Just in terms of like quantities. Yeah, a fifth of y. Yeah. So a fifth of y, right? And so again, we need to find y over x, right? So what's y over x? Mm-hmm. 3 over 20 divided by 1/5, because we can divide both sides by 1/5 here. And so that's 3/4. Yeah. So we have y over x, which is 3/4. Now we want to find the percent. So that's easy. That's just 3/4 times 100%. So it's just going to give us 75%. And that's C, the answer there. So like percents is always a ratio. Um, so since ratios are always over 1, a percent is that ratio, but then divided by 100. So you have to always, when you're thinking of percents, always think about this relationship. So it's like x over 100, so that ratio over 1 is equal to whatever that ratio will be out of 100. That's the percent. So this is the percent. So 15 over 100 is basically 3 over 20 out of 1. So that's why you multiply 3 over 20 at 3 over 20 by 100 to get that it's 15%. Or you multiply 1/5 times 100 to get 20%. It's because 1/5 over 1, that's you're basically translating that and then multiplying both top and bottom by 100% to get whatever the fraction is divided by 1. You want to get that over 100. So that's how percentages are. And so converting that to fractions, you saw how much easier the problem became. And then you can just, to get the percent, you can just multiply by 100 again. So yeah, I think that's all we have time for today. And you can close it up. Yeah. Yeah. All right. All right. Bye, guys.